Greetings and salutations, everybody. This is Jacob. A train of length of a third of a mile is traveling on a track at a speed of 20 miles per hour. A passenger who's running late is standing at a distance of 1/4 of a mile from the track. When the train reaches the point of the track that is closest to the passenger, which is 1/4 of a mile from the passenger starts running to catch the train. The question is, if the passenger runs in a straight line, how slowly can he run and still catch the train? And in which direction should he run? Pause the video if you'd like to give this problem a try. And when you're ready, put the smack down on the play button. Alright, so how do we go about solving this problem? Seems complicated, doesn't it? So, in order to find the minimum speed needed for the passenger to catch the train, the passenger needs to catch the train at the very end of its length. At the rear right corner specifically, as shown in the diagram. Make sense? And he needs to be running in the same direction as the train, which is to the right. If he, for example, runs towards the left, then higher speeds will be needed to catch the train. So, let's try to come up with a function of the passenger speed. We'll call the distance that the passenger traverses to catch the train d. T is the time that the passenger takes in order to catch the train, from the moment he starts running to the moment he grabs the rails. So what is this distance here? Since the passenger started running when the front of the train was at the point of the track closest to the passenger, then this distance here is the distance the front of the train traversed during this time minus the length of the train, which is 20 times t minus 1/3. So, now we can find the distance d through the Pythagorean theorem, which is d equals square root of 1/4 squared plus 20 times t minus 1/3 squared. The speed of the passenger is u of t equals d over t, which is square root of 1/4 squared plus 20 times t minus 1/3 squared all over t, which is 1/16 plus 400 times t squared minus 4 minus 40/3 times t plus 1/9 all over t. So, now we have a function of the passenger speed with respect to the time t. From calculus, we know that to find the extreme values of a function, we take its derivative and equate it to 0. So the derivative of u of t, using the product and the chain rules of differentiation, is u prime of t equals minus square root of 1/16 plus 400 times t squared minus 40/3 times t plus 1/9 all over t squared plus 800 times t minus 40/3 all over 2 times t times the square root of 1/16 plus 400 times t squared minus 40/3 times t plus 1/9. So we equate that derivative to 0. Do the calculations, all the algebraic operations, and we end up with two solutions. T equals 0, which physically doesn't make sense unless the passenger has some serious teleportation skills, which he doesn't. And the other solution, which is a bit more realistic, is 0.026 hours, which is 1.56 minutes. So now we can find this distance here, d1, which is 20 times 0.026 minus 1/3, which is 0.186 miles. Now we can find the angle at which the passenger has to run towards, which is tangent theta equals 0.186 miles over 0.250 miles, which is theta equals arctangent of 0.186 over 0.250, which is approximately 36.64 degrees. Now we can find the distance d that the passenger traverses in order to catch the train, which is 0.186 over sine of 36.64 degrees, which is approximately 0.311 miles. And so the minimum speed needed is d over t equals 0.311 over 0.026, which is 11.96 miles per hour. Now we're not done yet. We need to confirm that this value is indeed a minimum using the second derivative test. We need to find the second derivative, and if the value is positive at 0.026, then it is indeed our answer. So the second derivative is u prime prime of t. I did this with an online calculator because this is very tedious to do by hand. And I came up with this function here. You plug in 0.026 and you get a positive answer. So indeed, at t equals 0.026, we have a minimum speed of 11.96 miles per hour, and that's your answer. 11.96. Seems an intuitive answer, if you ask me. So that was an interesting optimization problem. I hope you liked it. Let me know in the comments below if you found it difficult or not. I have many more goodies in the pipeline for you all. algebra, logic, probability, optimization, calculus, differential equations, discrete mathematics, geometry, infinite series, chess, lateral thinking, everything under the sun, and then some. So if you like this puzzle, then put the smack down on the like button, destroy the notification bell. I'll see you guys in the next video. Bye-bye.